Good evening, one and all. My name is Angad Singh, and today we are going to derive the Darcy Weisbach equation for friction loss. So, as you can see, this is a pipe and through which fluid is flowing. So, this is our P1 and this one P2. This is the second pressure and the first pressure. The first pressure which is at the first section, and second pressure which is at the second section. So the pressure 1 is greater than the pressure 2 if fluid is flowing from here. So we apply the Bernoulli's equation, and this is how Bernoulli equation is applied, wherein HF is given as head loss, which is due to the friction. Because pipe is horizontal, that's why Z1 is equals to Z2, and because pipe is of uniform diameter, so V1 is equals to V2. So we get P1 by rho g is equals to P2 by rho g plus HF. How we get it? So basically, as Z1 is equal to Z2 and V1 is equals to V2, so this cancel outs, and as we can see, because the velocities are equal, this also cancel outs. So we get this equation. Now, as you can see, if we rearrange this, the HF is given as P1 minus P2 is equals to rho g HF. This is our equation 1 which we get. Now the next step is we will find the frictional resistance. For that, we will assume that F dash is frictional resistance per unit wetted area per unit velocity. Therefore, friction resistance is given by F dash into wetted area into velocity square. So this is the frictional resistance, which is given by F dash into pi dl into V square, and the perimeter is basically pi d. Now we calculate the net force which is acting on the fluid between the sections 1, and 2. So how do we do it? At section 1, the pressure is given by F1 by A. So frictional force which we get is P1 by A, which is in the positive direction. That means the direction of the fluid. And at section 2, P2 is given by F2 by A, which is opposite direction, which is our negative. So we get it as F2 is equals to P2 by A in negative direction, and the frictional force which is already in the negative direction. So when we resolve all the forces in the horizontal direction, we are left with this equation, which is P1A minus P2A minus F is equals to 0. So P1A minus P2A is equals to F. From here we basically take the A common, right, in both of these. So P1 minus P2A is equals to F, and then we get P1 minus P2 is equals to F by A. Now from here, in the place of F, we put the friction resistance. This is P1 minus P2 is equals to F dash into P into L into V square by A. And from equation 1 we get that P1 minus P2 is equals to rho g HF. So P1 minus P2, in the place of P1 minus P2 we write rho g HF. So rho g HF is equals to F dash into P into L into V square by A. So here we see HF is equals to F dash by rho g into L into V square into P by A. But what we know is that P by A is wetted perimeter by area. So wetted perimeter by area is given as pi d by pi by 4d square is equals to 4d. So we get HF as F dash by rho g into 4lv square by d. Now here we come with a new term. We basically substitute in the place of F dash by rho, we substitute F by 2, where F is the coefficient of friction. This is very important step. So in this we get HF is equals to F by 2g into 4lv square by d, and finally we get HF is equals to 4flv square by 2gd, where F is the friction factor and it is used for finding the loss of head due to friction in pipes. If you liked my video, then don't forget to subscribe to my channel. I would be uploading more tutorials. Thank you.